represent the t in this table here, it's alpha.
Okay.
And not all tables present this way. That's the way this book presents the t distribution. Okay, so okay, we have one claim that was okay, one claim that wasn't. Hypothesis testing, pretty straightforward. Anybody have any questions on hypothesis testing? How to run a hypothesis test? Pretty straightforward. Same thing with the confidence interval construction. Pretty straightforward in how to construct the confidence intervals. Same thing with hypothesis testing. And like I said, there's a few steps that you have to make sure that are correct. Don't forget, HO is the equality. As you see the equal sign here, so it's either going to be less than or equal to, greater than or equal to. That's always going to be HO. The test statistic is either a Z or a T, depending upon what box you end up in. The Z and the T calculations are pretty straightforward at the moment. Get a little more complicated next week. The decision rule is a function of how HO and H1 are set up. In this case right here, how are they set up? These are set up like A in the handout, correct? Equal to versus not equal to. So if you go to the third page, it says if they're set up like A, it's a two-tailed test. Now, why is this a two-tailed test and the other one's a one-tailed test? Why was the first one a one-tailed test and why is this a two-tailed test? Why do you think this is a two-tailed test?
Because it's just equals.
Because we're saying equal to, that means what? That could be less than or greater than, not equal to. They're both affecting what our decision is going to be. Whereas in the other one where we said it was mu was, what did we say? No, that was 20 minutes. It was less than or equal to 20 minutes versus mu is greater than 20 minutes. See, what happens is this is the null. The alternate is only a one-way. See, the greater than. That's why it's a one-tailed test. This is a two-tailed test because it could be less than or equal to. So we make sure that we put rejection regions in both tails. Here, it's just a one-way on the alternate, and it's which side? Where was the rejection region? On the right or the left when it was set up this way? Well, just look it up. It was on the right side, correct. And so well, I'll get to that as to why it's on the right side versus the left side, but I'll do that at the end of the class. And so let's do one with proportions. Then we'll confuse this one a little bit. More than 4 in 10 people more than 4 in 10 people love statistics. How's that? Yeah, that's that. I'm sure this is going to be
this is false.
Well proved. I didn't finish it.
You don't have to.
In death. I wrote it in death over here, okay? Or after death. Okay, so this is what we're going to test. All right, so here's the claim. So how do you, we're going to test whether this is true or not. So what's HO and what's H1? Are we talking about mu or are we talking about pi? We're talking here about pi. So we're saying what about pi?
Pi is greater than or equal to 4.
Is pi what? What are we putting in here?
Greater than equals to 4 over 10.
Greater than.
Great, yeah.
Not equal to.
Just tell me what you think we should put it in. Remember, this has to
Oh,
go in
greater
as,
than.
as-
Just greater than.
now remember, it's related to the handout.
Yeah.
You know, the second section of the first half has all the pies in there. And so, what are we testing here? More than 4 and 10. Well, what's 4 and 10 as it relates to percentages or proportions?
40%.
0.40. Okay, so we're saying what about 0.40? It says more than. And so the way I would designate it is pi is greater than 0.40, right? And so part of the examples that we're going to get in the homework and in the final exam is I'm going to give you a statement, and you have to translate it into HO and H1. I might say 4 and 10. I might say 40%. I might say more than. I might say at least. I might say at most. I might say equal to. I might say it's different. What does different mean?
Not equal to.
Right, not equal to. It's different. Could be higher, could be low. Okay, so when you see an example, it's not always going to say, oh, let's test if it's equal to, or let's test if it's greater than. It might be at least, at most, at whatever the question might say. And so you have to make sure that when you read it, you interpret it such that it's right when you put down HO and H1. And so here, we're testing is mu greater than 0.40. And so what's the alternate to this? Pi is what?
Less than or equal to.
Less than or equal to 0.40. And so, for hypothesis testing purposes, which of these two is HO? It's this one.
Second one.
So it's less than or equal to 0.40, and then therefore our test is actually, this time, it's in the alternate. We're testing the alternate this time. Or our test is in the alternate. Everybody see that? Okay. All right, so that's the first step. Second step, we'll say alpha is, do 0.10. We haven't done a 0.10 in a while. What's the third step? Take a sample of size n. And we'll say in this case n is equal to, I like 100. N is equal to 100. And let's say that x came in at 44. Okay? And then what's the fourth step in the hypothesis test? Test statistic. When you have proportions, what's the test statistic? Test statistic is what? On the handout. What kind of a test statistic do we have?
We're using Z.
Z. It's the one on the far right, where it says Z is equal to P sub H. I should write it. I don't even remember what it is.
Minus.
That's why I give the handouts. I'm like, I can't remember half the time what it is. It's P sub H minus pi, the hypothesized pi, over the square root of the hypothesized pi times 1 minus the hypothesized pi over n. And so, in this case, it's what? It's P sub H. Okay, what is P sub H? No, I'm sorry, it's not P sub H, it's just P sub S. Right. What's P sub S stand for?
Sample proportion.
Sample proportion. So what's the proportion sample? Well, the sample proportion in this case right here, given the data that we have.
0.44.
Right, because it's 44 out of the 100 said that they like statistics. Okay, so P sub S, in this case, you have to calculate it. I didn't give it to you. This would be 0.44 because it's 44 divided by 100. And so then we just plug it in here. So we have what? 0.44 minus 0.40 divided by the square root of 0.40 times 1 minus 0.40 over 100. Oops, over 100. And so what do we have here? We have a 0.04 divided by, let's see, 0.4 times 0.6 is 0.24, right? divided by 100 was 0.024. What's the square root of 0.024?
It's 0.155.
0.155. And so what's the test statistic? It's 0.04 divided by 0.155.
Is a 0.258.
0.26. Okay, so that's the test statistic. What's the fifth step in the hypothesis test, the decision rule? This is a Z distribution. Is this a one or a two-tailed test?
One.
This is a one-tailed test. Is the rejection region on the right or the left?
Right. Positive.
The right.
Right.
Wait. Why are you saying right?
Because it's positive.
What's positive?
The Z.
That doesn't mean anything. That's what I thought you were saying.
Yeah,
That's just a test statistic.
you're right.
That has nothing to do with the decision rule. That's what I'm saying. What you should do is you should be using the handle almost all the time. It's pretty straightforward, pretty direct. You shouldn't have to guess about anything. And so here it says that this is the decision rule. It's a Z, and it says what? It says, okay, it's definitely not a two-tailed test. Why? Because it's not equal to versus not equal to. It's less than versus greater than, and that's set up like B. And what's B? It's got the rejection region on the right. So it's over here. Okay? Now, it just so happens that you were right. That it's in the right.
But not for the reason I said.
Yes.
Mhm.
Yes.
Okay.
And so this would be accept HO. This is reject HO. Accept H1. And so all we have to do is find the critical value. This is Z distribution. And it's alpha. And so what's the critical value? We know it's a plus. And so if the area in the tail is 0.10, what's the critical value? With 10% of the area in the tail. Look up in the table. And so if 10 is there, that means that 0.4000 is here. So you look up the closest thing to 0.4000. You'll probably get something like 0.3998 or something. Anybody give me the,
1.29.
what is it? 1.29? Everybody see that? 1.29, is that the best one? Is that the closest one?
Yeah.
1.29? Okay, so this is a 1.29. No?
1.285.
Is that what? Okay.
Yeah.
1.285? Okay, I'll take that. 1.285? And so, so the decision rule is if the test statistic Z is less than plus 1.265, no, 285, then what do? Accept HO. Because if it's less than 1.285, that means it's over here. That's the accept HO region. If not, reject HO and accept H1. And so, what's the test statistic? It's a plus 0.26. That falls to the left of 0.1285. And so, what's our decision? It's to accept HO. So we accept HO. And what is HO? Go back over here. And we say that pi is less than or equal to 0.40. And what was the test that we were running? We said this, we were testing this. Oh, no, wait, let me go back. It says, yeah, less than or equal to 0.40, is that right?
Yes, so that means the statement is false.
Yep, so we get, so we're accepting this, and we're saying that it's less than or equal to 0.4, that the hypothesis was greater than 0.4, and so what's the answer to this? This is false. Correct? False. Once again, we see that even though this was a 0.44 relative to 0.40, that's not enough statistical evidence for us to reject HO. Because it's only 100 people out of what was on there. Okay, so there's not enough statistical evidence, even though you get a 0.44. And we're testing 0.40. You would think that we would be saying pi is greater than 0.40, but 0.44, not enough statistical evidence for us to make that claim.
If your Z were to land close, like really close to 1.285.
Yeah, let's say that this came like that, 1.26.
What would you need? What kind of data would you need to make that statement?
Okay, what happens is you go back this would 1.26. So everything would be we'll make the 0.04. So tell me what's 1.26. What's point? Is that right? 1.155. So I want to get x 0.155 is equal to 1.26. So it's 1.26x. What's 1.26 divided by 0.155? Is that right?
8.12.
8.12. 8.1.
1.26 divided by 0.55.
1.2, is that right? Because I
That's
want to make x divided by 1.55, because I want to make this dx, and that's going to be equal to 1.26. So 1.26, 1.55. No, it's 1.55 divided by 1.26.
0.123.
0.123. So this is going to be a 123. And so this has to be 52.3, 0.523. 0.523 makes that so that this comes up to 1.26. 1.26, still accepting HO. Okay, so you have to get, you know, like point, what did I say, 0.526 or something? It can be like around 0.54 before you can reject HO and accept H1 that U is greater than 4. So you need a lot of evidence, because, you know, 0.54 relative to 0.40, that's way out there. But the problem is that you only get 100 observations.
So you just have to try to attempt to...
No. I'm just saying that, because your question was, well, how much would it take for us to accept, to reject HO and accept H1? Meaning, he just showed was piece of S has to be at least 0.54, meaning 54 of these people. But you can't do anything. That's the data. The data came in at 44. You can't do anything about it. Now, if it came in at 54, and you include, that would be 0.54, you go through and you'd be like, wow, this is really close to the 1.285. It depends on where it is, dictates as to whether you accept or reject HO. Okay? All right, but the data is whatever the data is. You can't do anything with it or to it. You have to take it and say, okay, that's the data. Plug it in. Come up with your statistics. Run through the hypothesis test. make your decision about HO. Reject it or accept it. Based on the test statistic, the decision rule, Z or T distribution, and it's all related to central limit theorem, probability, and statistics. Okay? That's why I give a handout, because I'm saying to myself, now, we learned all this in the first quarter, or the first stat one, and so it's easy to have it in a nice, compact analysis so that you can use it whenever you want, whether in class or in public or whatever, and do your testing accordingly. And so, I think I saw another name. Is there another?
It's usually me.
Okay.
So if the critical value, rather than going with the 1.28, you went to the 1.285. Do
I
you?
didn't look it up.
Yeah, but I mean, should we, if it falls in between, are you looking for us to round it out?
For our purposes right here, if you did 1.28 or 1.29, I would have taken either.
Okay.
That's fine. That's fine with me. And one of the reasons why I would take it is because the Z was what? It was 0.26 or something. I mean, it's way over here.
Yeah.
However, you know, if it came around 1.28,
Yeah.
you know, then I
That's why
probably
I'm
say,
asking.
oh, okay, you know, you probably should have gone out on another one because it's
Okay.
really right on the line.
That's why I'm asking.
Yes.
Okay.
But you don't have to. I mean, for
Okay.
our purposes, if it's right on the line, which it really almost is never going to be, you know, you don't really have to refine the critical value. I mean, in the real world, yes, you should. However, when the test statistic was so far to the left, it doesn't matter if you rounded it or not.
But if it's right on the line, is it accept or is it reject?
It's a good question. It's a good question. Because the other thing is, when we get to the, I don't know if in a minute, I don't think it's this week or it's not this week or next week. I'm trying to look at the p-value. Where does the p-value come into, what chapter is the p-value in? Is it in this chapter or is it in the next one? Let me think. Let me see here. Yeah, it's in this chapter, but I'm not going to go over it. I'm going to go over it next week. The p-value and hypothesis testing basically tells you that how's the evidence that we have. Is it some evidence, strong evidence, very strong evidence, or extremely strong evidence? And basically, it's a function of how far away is the test statistic from the critical value. If it's really far away, we get strong, what does he say here? Extremely strong evidence. If it's getting closer, then we have some evidence. And so that's kind of what the p-value says. It says that when you say this, when you accept HO, that pi is less than or equal to 0.40 at the 0.01 level of significance, the p-value will say, oh, and there's strong evidence of that. So it gives the reader a little bit more. The reader says, oh, I know what that means. I know that the test statistic is falling close to the critical value or far away. And the farther away we say, oh, it's extremely strong evidence. Okay, but that'll be next week. Okay, and I think you have, did you have a question?
Yeah, I was gonna ask you how you got the critical value, but that's when you go back to the chart.
Yes, 1.285. Now the 1.285 here is a Z. 0.10 in the tail. That means 0.40 here, because area to the right is 0.5. So what you do is you go in here, you look up the closest thing to 0.4000, and I'm told it was 1.28. So if I go to 1.28, we get the 0.3997. That probably wouldn't have been 1.285. Probably should be like 1.283. But whatever. Did you see it?
Yeah, I got it.
Okay. Okay, so let's just go through the textbook just for a second here. One sample test of hypothesis. Page 335. What is hypothesis testing? There's a little definition there. It's the book. I'm on page 335. It says here on page 335, 5-step procedure for testing a hypothesis. I have 6. All I did was I took the step 5. See what step 5 it says, take a sample, arrive at a decision. All I did was I separated step 5 into 2 steps. Null hypothesis, alternate hypothesis, level of significance explained on page 336, 337. Type 1 error, type 2, no big deal as to what those are. Type 1 error, rejecting the null hypothesis when it's true. Type 2 error, accepting the null hypothesis when it's false. You don't really have to get too much into that, other than to say, oh, is there a type 2 error? And you look at this and you say, oh, okay, it's accepting the null hypothesis when it's false. Critical values on page 339. There's the test statistic on page 338 for Z. P-value we didn't go over, maybe we'll do it next week. There's the test statistic on page 348 for a T. We did proportions, test concerning proportions on page 356. Type 2 error, just not a big deal, you really don't have to go through that. And that's that on this chapter. So, that's this class.